This video covers the configuration of the HolidayCoro 4-output long-range regular receiver. This item code here is 951-65, and this board may look slightly different from a board you have based upon the type of fuse that you have. What is in common is that there are 4 outputs, 1, 2, 3, 4, and we have one jack here. You will notice that the jack is red inside, and we have it powered up. We'll also see that there are 4 red LEDs. The 4 red LEDs next to the fuses indicate that the poly fuses are not tripped. These are self-resetting. If you trip a fuse, just wait about 5 minutes and it will reset. We have a red LED light over here that indicates that the unit is powered up. So we're going to go ahead and plug our Cat 5 cable back in here, and let's track that back to where it gets its signal. And in this particular setup, what we're going to do is we're going to be using this controller. Now this controller happens to be a Hinkspix Pro version 2, and that CPU will work fine with this receiver, as will the Alphapix. We will configure both controllers as they both work with the regular receiver. Now, in this particular configuration, we are using the long-range receiver on the first jack. This is jack 1, 2, 3, 4. You'll notice it's on the left next to the hinges, and this is comprised of ports 1 through 4, 5 through 8, and so on. That means that each of these jacks has 8 wires or 4 pairs. Those 4 pairs of wires directly correspond to each of the outputs on the receiver. A long-range regular receiver is nothing more than a normal 16 regular SPI board, except that we have added the long-range component over this cable. All right, so coming out of this, you can see an orange cable, and it goes out of the bottom of this box. It then arrives at the bottom of this receiver box, which is fully assembled, goes up and into this left receiver. We will not be using this right receiver, and you can see that the cap is on that particular unit. When our signal comes in from the orange wire, it goes through this gray cable and goes in here. Now, we again have outputs 1, 2, 3, and 4, and we have some pixels connected to those. On output 4, we have some seed pixels, and on output 1, we have some traditional pixel nodes that are 12 millimeters. All right, we're going to set up outputs 1 and 4 to operate today. All right, now, let's go ahead and go over to first the Hinkspix Pro. So let's turn this off. What we're going to do is first show you the configuration of the Hinkspix Pro. This is version 155 of the firmware. Next, we're coming over to port config 1 through 16, and we're going to look at the configuration here. Here we can see all 4 of the jacks in groupings, and these are each of the pairs of wires that go down, and we can see that there are no pixel counts configured. If we go to the E131 tab, we can see that there's basically nothing here. Okay, so the first thing we want to do is go into the design tool, and you can go ahead and create multiple designs and save them for future reference. So you can have a configuration that varies based upon a particular season or a particular show, and then load each of those configurations individually. If you do, they'll be listed in this drop down here. All right, the first thing we need to do is we need to say this is a long range. So we're just going to go ahead and configure one long range. Now, if you're configuring SPI boards, you would add SPIs here, but that's not what we're configuring today. Now, as I mentioned, we have our long range board, in this particular case on 1 through 16. So Hinkspix Pro ports 1 through 16, and we're just going to say long range board 1 is what we're going to put there. Then we're going to say we have a cable hooked up to it, and we're going to turn on that cable. Now, what it now tells us is we have a long-range receiver that's going to be attached to cable 1 that will be plugged into this receiver or this long-range expansion board here. Now, first thing we need to do is go ahead and add some strings. Strings are just simply the objects that you're controlling that have the pixels. So I'm going to go ahead and hit add more strings, and we're just going to say long range regular output 1. All right, and this is just for our reference. It doesn't change anything in the system, and we're going to go ahead and configure the universe and channels. Now, in this particular case, what we're going to do is going to go ahead and pretend that there are more than 170 pixels on output 1. If we do that, what we'll do is we'll put in a universe 1, and universe can be, of course, any universe that's appropriate for your system within your scope. Configure that relative, of course, to your particular application that you're using. So universe 1, and we're going to go to channel 510. Now, if you have more than 170 pixels on a single output, the controller will automatically roll over into the second output or second universe. So universe 1, and then let's just say we have universe 2, and that's going to be, let's say, 150 channels, which is 50 pixels. So we have 170 plus 50 pixels. And here we're just going to configure 150 channels, which is 50 pixels. So here we have 170 plus 50 and 50 pixels on output 4. Oh, actually, here, 4. There we go. All right, now that we have them, we're going to come down here and we're going to choose from the type of receiver we have. Now, in this particular case, we're going to be doing a regular SPI. That is one that's not smart. A smart is identified by having 3 jacks or Cat5 cable connections on it. This only has 1. All right, here you'll see that sometimes regular is referred to as dumb. All right, now what we're going to do is just go ahead, and you can see here we have physical port 1, 2, 3, 4, and because we want to hook up our first one, we're going to click in here, string, and click into the string that we want. And you may hear a beep on your computer that indicates that it has been mapped. And we're also going to configure output 4. We're going to click there, it turns green, and we click on output 4. So you can see it's taken the name from the string and put it in here. Now, what we're going to do is just go ahead and sanity check this. It says, great, your strings are good. All right, we're going to go up here and perform a design check. That just checks everything that you configured. If you've over exceeded a particular output configuration or done something that is not physically possible to build, that would appear as an error here. All right, so everything is good. Now let's save this. So we're going to say LR regular, and we're going to call it output 1-4, for example. All right, we're going to go ahead and save that. It says it has been saved. Now, you will have to, of course, save this to an SD card. So, if you do need to know if you have an SD card in your controller, you can come over here and look at the debug tab and see that it says SD card mounted. All right, so now that we've saved that, and if we want to see that, we can actually refresh the page, and you can see that it's now appearing here. We need to load this. Now, this is not loaded into the controller, so if we go back to the long-range port configuration, we'll see that still nothing's here in the setup. So we're going to go to Manage Controller Configurations. We will choose our long-range regular output, and we'll install that. It says it has been set up, and we need to reset. So just come over here to the reset. This will reboot the controller with the new configuration. And I'll be right back when that's rebooted. All right, our controller is now rebooted, and we're going to go into the port config and show you how it's now configured it. So here we can see that there are 220 pixels on that first jack or output and 50 on the second. Now, you may notice that there's no receivers here, and that's because this is not considered a smart receiver. It is considered effectively an SPI output. All that's happening here is data is simply being pushed down this Cat5 pair of wires into that long-range receiver, and that makes it perfect for distributed outputs at a longer distance. So how do we test this? So you could, of course, test this from your application, but we can also test this from within the controller on a Hinkspix. Go to Test Outputs and simply go to the long range expansion board and then check off the port that you want to test. Now in this particular case, we're going to test port 1 and we're going to say blink red, and I'm going to turn this camera back on, and you can see here again this is the output 1 and these are blinking red. so that indicates that they are operational. You'll notice that the seed pixels are not blinking. All right, so let's go back to our interface here. We'll just turn on port 4. So we'll turn that off, go over here, and we'll say blink green. Okay, so we'll turn camera back on here, and you can see we are now blinking green. All right, that's how easy it is to set up the Hinkspix to work with long range. Now, let's go ahead and configure a Alphapix Flex with the same setup. All right, hold on one moment here. We're just going to clear all of those. All right, I've gone ahead and logged into my Alphapix Evolution controller. And by the way, this video does not cover the networking involved in connecting any of these controllers to your network. See our other videos for that. In this particular case, what we have is we have long-range differential board. The controller can see if it has a long-range board or an SPI board connected. It must be, of course, be a differential long-range board. Now, remember that these are connected in blocks of 4. So output 1, 2, 3, 4 is output 1, 2, 3, 4, but 5, 6, 7, 8 is 1, 2, 3, 4. So output 5 is output 1 on the actual receiver, 2, 3, and 4. All right, and if we were going to configure those in the same way, we would simply come in here. If we were doing 220 pixels, we would simply say that. And in this particular case, we do need to roll this over so that Universe 1 will roll into Universe 2 automatically on this controller, just like the Hinkspix. And we are going to then set up 50 pixels, because this is not by channels, this is by pixels. And we would simply change that number. And actually, no, we wouldn't. We would do, let's say, this could be 3, but it also could be here. So let's do 3 here and do 50. It doesn't matter if it's here or not. So I made a mistake because we are configuring output 4 to work with Universe 3 with 50 pixels. Now you do have a couple of options here. You have null pixels, which are dummy pixels that just repeat data. You do have zigzag addressing if your application doesn't support that, and you can address this in limit intensity to a specific percentage output. Normally it's 0 to 255, but you can limit that at the control level, and you can reverse the addressing so that it can go backwards, so that the pixels at the end of the string are actually at the front of the string, or vice versa. All right, once you have that, you simply just update the port, the controller will reboot, and your setup will continue working. All right, now if you wish to do a test on this, let's wait for this to reboot, and I'll show you how to do a test on the Alphapix. Our controller has now rebooted, and if you wish to test the pixels, you can simply come down here to Test Mode Configuration, Configured Lights, update the test mode, and it will output data to all configured pixels on the controller. You can also implement this mode by pressing and holding the left M, as in Mary, button on the controller's interface, and it will also put it into test mode. That completes the entire setup of the long-range regular receiver from HolidayCoro. If you ever have any additional questions, reach out to us at holidaycoro.com/contact us.